This is what Port-au-Prince, the capital of Haiti, looked like on January the 11th, 2010. And this was the same city 24 hours later.
Everybody was calling Jesus, Jesus, Jesus.
The city was flattened by a massive earthquake measuring 7.0. More than 230,000 people died. 250,000 buildings were reduced to rubble.
The Haiti earthquake of January 12th is the 5th largest killing earthquake in history.
But it was not unexpected.
There was a police station there. You can't see anything, and that's because there's nothing left.
But almost 2 years before the quake, geophysicist Eric Calais saw this coming. Along with his colleagues at the Haitian Bureau of Mines, they actually forecast this earthquake with amazing accuracy.
With the University of Purdue, we calculate the magnitude of the earthquake, and we have found 7.2. And we knew that this earthquake will be very, very catastrophic. Yeah.
They did it by measuring Earth's movements along the Enriquillo fault zone. The Enriquillo Fault, a giant crack in the Earth's surface, runs the entire length of Haiti. If you could peer underground, you'd see a complex jumble of jagged fissures where pieces of the Earth's crust rub up against each other. The two sides of the fault drift in opposite directions. Eric's team set out to measure the speed of the two moving plates. In 2003, they placed 6 steel pins in key locations on both sides of the fault.
It's a piece of metal, stainless steel, that we sealed at the top of this building.
On top of each pin, Eric attached a GPS antenna linked to a satellite 12,500 miles up. The global positioning system can detect even the tiniest movements of the pins, showing Eric that the two sides of the fault are moving about 1/4 of an inch away from each other every year. It doesn't sound like much, but it makes a big difference because the two sides don't slide smoothly. Friction keeps the rocks locked together and tension builds up.
What we saw was a fault being loaded just like a rubber band.
Eventually, the rubber band snaps. The result is an earthquake. But how powerful would the earthquake be? Eric did a simple calculation. The speed of the two plates, 1/4 inch or 7 millimeters per year, times the number of years since the last known big earthquake, 250.
7 times 250 is about 1.8 meters. So there's 1.8 meters of motion that could be released.
In 2008, Eric forecast an earthquake of magnitude 7.2. It was tragically accurate. All that was lacking was a time frame.
It's not that we were afraid to put a date on it, it's that as a scientist, we can't.
The timing of some natural disasters is predictable. For example, a hurricane's path can be seen and measured. Its time of landfall can usually be predicted to within an hour. But earthquake scientists are at a huge disadvantage. The powerful forces they study are hidden from view deep underground.
The core of the problem is at depth, 15 kilometers, roughly speaking. That's the place where we would like to be making our measurements. I would give up my GPS instruments and my surface measurements if only I could have measurement of the forces inside the Earth.